These are notes for section 2.1 through 2.4. It seems like that would be a lot to fit into one video, but a lot of what we have in these 3-4 sections builds on what we already discussed in chapter 1, as you'll see. So chapter 2 deals with inequalities, and inequalities are the inequality signs, not an equal sign, but an inequality sign. So there's 4 of them. We have less than equal to, greater than equal to. So an example of an inequality, 6 is less than 10. Well, that's true. 6 is less than 10. Or you could say -4 is greater than or equal to -7. That's true as well. -4 is greater than or equal to -7. What we're going to be looking at are inequalities dealing with inequalities dealing with variables, and we're going to be graphing them to represent our solutions. So something like x is less than 2, numbers less than 2. Well, there's a whole bunch of numbers less than 2. 1, 0, -1, -2, -3, -4. It's a bunch of them. And so what we're going to do is use a graph to represent these solutions. And in order to graph, there's a couple of things we need to do. The first of which is to figure out whether or not we have an open or closed circle. And I'll talk more about this as we get the examples. But an open circle is just a circle that is not filled in, and that is either going to be less than or greater than. And a closed circle will be a circle that's filled in, and that's less than or equal to, or greater than or equal to. Very few kids have issues with the circle part. Where kids struggle on is figuring out which way to shade, which way to go left or right on the number line. So a couple of examples. On number 1, it says x is greater than or equal to -6. So on my number line, I put 0 and -6. On number 2, 0 and -5. On number 3, 0 and +10, 10 being to the right of 0. And on number 4, 0 and -4. Okay, easy enough. Then I look at my inequality. On number 1, greater than or equal to means I have a closed circle. On number 2, less than means I have an open circle. Greater than means I have an open circle. And you could say less than or equal to means I have a closed circle. Okay, those are my circles. Now there's 2 sides to the -6. There's that direction and there's that direction. I need to shade the side that has the numbers that make it true. For example, if I picked 2 over here on the right, just +2, and I plug that in for x, is 2 greater than or equal to -6? That's true. That means my solutions are this direction. We could also simply look at the arrow if it's pointing to the left and say that I can shade on number 2 to the left. Numbers less than -5. They're to the left. The only catch is if it's written backwards, although there's no such thing, but let's just say it is, I would suggest that you rewrite this inequality so the x is on the left-hand side and the arrow is pointing at the x, which means it still needs to be pointing at the x. And now if the arrow is pointing left, I shade left. Another way, and we've discussed this in class for the last 2 days with the students, but you could say if the x is on the right-hand side, you shade opposite direction the way the arrow is pointing. There's like 4 or 5 different ways you could talk about which way to shade, but it's important that we shade the correct direction. And the direction is wherever our solutions are, wherever the numbers make the statement true. Meaning everything in this shaded region on number 4 would make this inequality true. Everything on number 3 in this shaded region would make this inequality true. We're trying to find the solutions, which gets us into solving. And the nice thing about inequalities, and which is why we spent 6 weeks in chapter 1, is they solve a lot like equations. Now you can see I have some yellow asterisks up here. There is one catch, which I'll go over here in just a minute. But as far as the general rule, distribute, combine like terms, pick on the little guy, get the variable by itself. All of the stuff we did in chapter 1 still carries over. So on number 5, if I were to get rid of a plus 3, I would subtract. If I were to get rid of a divide by 2, I would multiply. I'm doing inverse operations just like I did in chapter 1. X is greater than negative 14. Now it doesn't ask us to graph, but we could certainly put one on here. Negative 14 on the number line. Greater than is an open circle. Arrow points right. I shade right. On number 6, there's no distributing. There's no combining like terms. I need to pick on the little guy. To get rid of a minus x, I can add x. To get rid of a minus 7, I can add 7. To get rid of a times 3, I can divide by 3. Again, all of these steps are exactly what we did in chapter 1. Close circle at 6, equal to, arrow points right, shade right. And on the last one here, number 7, to get rid of the parentheses, I distribute. That's multiply. There's no combining like terms. There's no picking on the little guy. I need to do inverse operations. Call it opposites if you wanted to. To get rid of a plus 15, you subtract. Get rid of a times 3, you divide. My solution is negative 2 greater than or equal to x. Again, closed circle. And since the x is on the opposite side, we can shade opposite the way the arrow is pointing. So the solving, a lot like we did in chapter 1. The catch, the 3 asterisks, is if you multiply or divide by a negative, you have to flip the inequality sign. We picked this up today in class. I went over it, but this is the rule. If you multiply or divide by a negative, the inequality sign needs to flip around. For example, on number 8, if I were to solve this, I would divide by negative 2. Well, those go away. Negative 18 divided by negative 2 is positive 9. And according to this rule, I divided by a negative, so I have to flip the sign around. And the reason I need to flip the sign around is if I don't, my graph will have the exact opposite wrong answers. What I mean by that is, let's say I don't flip it around. Let's just say I didn't flip the sign and I still got x is greater than 9. Well, a number bigger than 9 would be something like 10. So 10 should make that work. Negative 2 times 10 greater than negative 18. Negative 2 times 10 is negative 20. Negative 20 is not bigger than negative 18. That is incorrect, which is why we need to flip the sign around. So anytime you multiply or divide by a negative, flip the inequality sign. On number 9, to get rid of a plus 4, you can subtract. To get rid of a divide by negative 2, I can multiply by negative 2. So that would be negative 10. And again, if I multiply by a negative, I have to take the sign and flip it around. So if you multiply or divide by a negative, flip the sign around. Last one here on number 10, to get rid of a plus 3, you subtract 3. To get rid of a times 2, you divide by 2. A lot of kids will look at this and want to flip the sign. They say, well, I got a negative answer, so I flipped the sign. No, I divided by positive 2. I divided by positive 2. If I divide by positive 2, that means that I don't flip the sign and it stays the same. Last thing. Again, this seems like a lot to put in, but a lot of it is carryover from chapter 1. So there's not too much new stuff other than, the graphs and then the flipping of the sign. So just like with equations, we can have multiple solutions or different types of special case answers, which are no solution and all real numbers. Again, this is a topic we talked about in chapter 1. On our first example, to get rid of a minus x, I can add x. To get rid of a plus 6, I can subtract 6. And to get rid of a times 2, I can divide by 2. Solving, same as it has been. If we have no solution, again, the solving doesn't change. We still distribute, combine like terms, pick on the little guy, get the variable by itself. So I combine my like terms. 2x and 2x are the exact same. It doesn't matter which one I move. The x's go away. 4 less than negative 5. Is 4 less than negative 5? Well, that's obviously false, so I say no solution. And on the last one here, when I combine like terms, it's 3x minus 5 greater than 3x minus 10. Again, variables on both sides. I pick on the little guy. It doesn't matter which one I move. They're the same. It's a 3. I'm left with negative 5 greater than negative 10. That is true. Negative 5 is bigger than negative 10. That's a true statement. If we don't have any variables left and I have a true statement, my answer is all real numbers. Hopefully that was helpful, and reach out to me if you need some more assistance. Thanks. Bye.